Physics Part 227. The variation with driving frequency f of the amplitude a of the vibration of the mass is illustrated in the figure. This graph is often called a resonance curve. Resonance occurs when the natural frequency of the vibration of an object is equal to the driving frequency, giving a maximum amplitude of vibration. The effect of damping on the amplitude of forced oscillations can be investigated by attaching a light but stiff card to the mass in the figure. Movement of the card gives rise to the air resistance and thus damping of the oscillations. The degree of damping may be varied by the changing the area of the card. The effects of damping are illustrated in the figure. It can be seen that as the degree of damping increases, the amplitude of the oscillation at all frequencies is reduced. The frequency at maximum amplitude shifts gradually towards lower frequencies. The peak becomes flatter. Barton's pendulums may also be used to demonstrate resonance and the effects of damping. The operators consist of a set of light pendulum made, for example, from the paper cones, and a more massive pendulum, the driver, for example, from paper cones, and a more massive pendulum, the driver. All supported on the taut string. The arrangement is illustrated in the figure. The lighter pendulums have different lengths, but one has the same length as the driver. This has the same natural frequency as the driver and will therefore vibrate with the largest frequencies of all pendulums. Adding weights to the paper cones reduces the effect of damping. With less damping, the amplitude of the resonant pendulum is much larger. There are many examples of resonance in everyday life. One of the simplest is that of pushing a child on a swing. We push at the same frequency as the natural frequency of oscillation of the swing and child, so that the amplitude of the motion increases. The operation of engine of a vehicle causes periodic force on the parts of the vehicle, which can cause them to resonate. For example, a particular frequency of rotation of the engine, the mirrors may resonate. To prevent excessive vibration, the mountings of the mirrors provide damping. Musical instruments rely on resonance to amplify the sound produced. The sound from a tuning fork is louder when it is held over a tube of just right length, so that the column of air resonates. We have met this phenomenon in our previous chapter in connection with the resonance tube method of measuring the speed of sound in air. Stringed instruments have a hollow wooden box with a hole under the strings, which acts in a similar way. To amplify all notes from all of the strings, the sounding box has to be a complex shape so that it resonates at many different frequencies. A spectacular example of resonance that is often quoted is the failure of the first suspension bridge over Tacoma Narrows in Washington State, USA. Wind caused the bridge to oscillate. It was used for months even though the roadway was oscillating with transverse vibration. Approaching vehicles would appear and then disappear. As the bridge deck vibrated up and down, one day strong winds set up twisting vibrations, and the amplitude of the vibration increased due to the resonance, until eventually the bridge collapsed. The driver of a car that was on the bridge managed to walk to safety before the collapse, although his dog could not be persuaded to leave the car. Next, we have got the section summary, and it's a very interesting tale about the bridge collapse.